Welcome to Overclocking TV. Today we are at the Gigabyte factory in Nanping in Taiwan, and we will show you how to make a motherboard from A to Z. A motherboard uses a lot of components, and all of them are assembled on a PCB. PCB means printed circuit board, and this makes the final mainboard you all know that is in your PC. The PCB arrived from another factory, and the first process is to solder on the board or the SMD. SMD means surface mounted devices. SMD is a term used for all the components that don't have pin going through the other side of the PCB, but have the electrical connection on the edge, like the audio chip, or below them, like the chipset. Every part of the PCB that will be in electrical contact with the component gets a special soldering pass. The solder pass acts like a glue for all these chips before going to the reflow oven for definitive soldering. In that way, every small component can stay in the right position before soldering. As you can see, solder pass is applied to only the PCB space where you will have a component. All the motherboards today have really thin and small components that are directly placed on the board, called SMD, surface mounted devices. The high-speed chip placer can place from 5 to 10 components per second. It's really fast. Most of the components mounted in this machine are around a millimeter wide and must be very precisely disposed on the PCB. Today, motherboards have components on both sides. The first side that goes to the factory process is the back. Once the back side is done, a machine switches the motherboard to the other side and the process starts again to the SMT line. After all the small components, it's time to put on the motherboard the chipset and the chip that will make your board working, as well as the CPU socket. Before being disposed on the motherboard, each chipset is verified by a different set of lights to check if there is any problem about the soldering point or alignment of the chipset itself. You can see all the chips like audio, SATA and USB 3. They are disposed on the board directly by this machine, as well as the CPU socket. As example, all the chips bigger than your finger is placed by this machine. At this time, your motherboard has SMDs on the board and can go to the reflow oven for soldering. The soldering pads melt by high temperature and stick to the component and the PCB. The temperature goes up to 245 degrees Celsius by different levels. At this point, electrical connection and mechanical connection are made. Your mainboard now have all the small resistors as well as the chipset and the socket. It's time for the visual inspection. This inspection avoids any misplacement or missing parts. Components smaller than 2 mm can't be checked by human, but the AOI is there for it. The automated optical inspection machine is checking if there is any missing or misplaced component. It's also checking all the components that have visible soldering points, like the audio chip. And finally, the ICT integrated chip tester can verify if every chip that have soldering point below them, like the chipset, are well connected. It does test if the chipset is well soldered electrically to the board, but not if the chipset is working itself. There is a dedicated floor for the new verification, especially for server components. Some boards are tested by X-ray to verify the quality of the soldering. This inspection is high-quality service that allow very high-end and server board to be checked for more in-depth analysis. Once this last testing is made, it's time to go to the DIP Dual Inline package. The DIP stage is the second big important process when making a motherboard. First, you have a manual insertion. All the small components and the chipset has been added already. It's time to plug all the other components that have been going through the PCB. During this stage, all the components are manually inserted. You can see a long chain of employees inserting the in-out connectors, power plug, PCI Express, RAM slot and other the chokes and the solid capacitors around the CPU socket. Before being definitely soldered on the board, each inserted part needs to be in the right place and well positioned. This is the goal of the inspection before the wave soldering. The principle of the wave solder is easy. The motherboard has its latest component on one side, with pins going through the PCB to the other side. The wave solder comes and touches the back of the PCB and pins with soldering iron melting, and that way components are soldered to the board. After the wave soldering process, you usually have residues that are cleaned with a large brush, making the back of your motherboard very shiny. Another inspection is made with some adjustment with solder iron if needed. Then heatsink are mounted on the board before another inspection and checkup by the ICT Integrated Chip Tester. Your board is now fully functional, but the biggest quality control still needs to be done. Employees are testing everything from the connectivity to the burn test of the main board. The function box allows easy switch on switch off of the component as well as the peripheral for the testing purpose. As part of the Gigabyte quality testing, 100% of the motherboard are tested in the factory. Basic to advanced functionalities are being verified. Once the board passed all the testing and quality analysis, the board is referenced and sent to the next process. This is the final step for your motherboard, and this is the box you will see in the shop. At the factory, the boxes are just flat, cardboard, but then quickly shaped by an automatic machine. Employees are sticking barcode and reference number on the boxes as well as the board, then scan the different serial number. Your board is now almost ready. You just need to put the accessories, manual, driver CD and close the package. Each box goes to big packages that are weighted then strapped. This is the end of our videos, and now you know exactly how is made a motherboard. We hope to see you soon and enjoy overclocking TV videos. Hey guys, Truffman from Overclocking TV, and we are in the Gigabyte factory and we just found something very crazy. Come on. 1, 2, 3, 4.